This is Jack Jackson. In this video we're going to continue to look at the side angle side postulate, and we're going to use this part of the sketch right here called side angle side 2. This is from my sketch Triangles Ultimate, and we go to SAS 2, and in this particular one we get to enter in values for two of the sides. The blue side, A, right now it's set at 6 centimeters, and B, 4 centimeters. So the blue side and the red side are determined by entering values on these parameters up here. And then we also enter a value for this angle C. And then we see that the rest of this is determined. So let me just show you how this works. If you just double click on this, we can put in another number we want. So any number we want. Let's say we want 10 centimeters here. And let's say we wanted, how about an obtuse angle this time? How about 120 degrees? And then let's go shorter here. Let's go 2 centimeters here. And this draws the triangle with those links. And if you click on this, it'll show you the measurements of the other side. So the side C, opposite angle C, is 11.14 centimeters. Angle B is 51.05 degrees. Angle A up here is 8.95 degrees. By the way, notice the standard labeling here that we're going to use often in this course. We'll label the vertices capital A, capital B, capital C, and really we should use a different letter for the measure of those angles, maybe Greek letters, alpha, beta, gamma, but we're going to kind of play loose with that notation and let the letter A represent, capital A, represent not only the point A, but also the measure of the angle at A. So here A is actually equal to 8.95 degrees, and we also use the same letter for that point A. But then lowercase a is something completely different. It's go to the other side, and it should be that side, and this one is labeled incorrectly. So let's fix that. I can fix that here. Side A, this one opposite should be angle A, and the one opposite B here should be angle B. So let me fix that. And I do have C and C opposite, and I think things relabeled themselves here. Maybe or maybe not. Things did not label themselves correctly. Okay, these are labeled correctly, these are not labeled correctly. So this one is angle B. So let me label that B. And we'll label this one angle A. Okay. So the 51 degrees is this angle down here, angle A, and angle B is this one here. Okay, angle C is the 120 degrees. It is calculated correctly. It's just not labeled correctly. Now, later on in the course of a trig course, we'll learn some things called the law of sines and the law of cosines, which will allow us to compute these things numerically. At an early point in the course, we might just compute these simply by drawing the thing with a compass and a straight edge and a ruler. In this case, all you really need is a ruler and a compass, and we can draw this. So, for example, here's how we would go at constructing this. The first thing we would do is pick a point. We'll call it A prime. And the next thing we do is we're going to make an angle there that in this case is 120 degrees. So we just use our protractor to pick that. So one will be going along 0 on our protractor, the other one will be pointing on 120 degrees. The next thing is we take our A, pick one side, it doesn't matter which one, and go out an angle, go out a side length there, A, B prime. Yeah, this is I want to relabel these things here. Let's relabel this C prime. And this one A prime. Okay. And let's see. So that's point C prime. And we're going to measure angle C. Or we're given angle C. And we want to, so this is C prime is there, and the ray with the endpoint at C prime. And this tells us how to do it in Sketchpad. We pick that and choose transform mark center. We want to measure angle C right here. Select it and choose transform mark angle. Select the ray emanating from C prime. Choose transform rotate. This will construct the angle down here at C prime, the one that we have here, which is congruent to the angle here at C. So, straightforward there. Use your compass or ruler to construct a circle centered at A prime of radius from C to A, which we're calling length B, and set this point A prime where those meet. And you can really pick either side of that angle. So C prime to A prime, so the thing we notice is that C prime to A prime is the same as from C to A. Okay, so that's the next step. Next step we do is we go out this length A. So let's go ahead and label that as length A. Okay, and that circle here has that radius, and that's going to give us our point up here, which is going to be B prime. Okay, and so we want the distance from B prime to C prime to be the same as from B to C. And of course B to C, we're calling that distance A. And let B prime be that intersection point. And that's the angle here. And so B prime, C prime equals BC, which equals A. Okay, and then finally we have everything that we need, so we just simply, to finish it out, we use a straight edge to draw A prime, B prime, and note that it's the same as from A to B, which is C. Okay, and so everything that we have there is we have the two triangles are congruent. So that sort of steps you through how you would do it by hand. Okay, or in Sketchpad if you had to build it up. But the nice thing about this also is this particular sketch, once you try one of these by hand, you can sort of check it with this sketch. And this is actually drawn to scale. If you were to print this out, it would print out to scale, or you can actually copy. For example, I can copy portions of this if I want. Like if I just want to copy this, for example, let's say I want to copy, back. If I want to copy, say, just this part, and then maybe, oops, I should have held down Control. This part here, get rid of these, but pick these up. Control C, go to your Word document, Control V. That's going to paste it where this actually really is, 11.14 centimeters long and so forth. And the B is actually 2 centimeters. So if I were to print this out, it'll print out the actual measurements that it says here. Or you can print out this whole thing directly from Sketchpad by just saying File, Print. So this allows you to print out some examples, print out some notes. You can go in and get this Sketchpad sketch and experiment with this yourself and just kind of play around with these numbers and see what you come up with. Look at many examples dynamically as we go along, and we also get a chance to use this for some printed notes if you want to print, or you can just get on here and look at it. So you can experiment with this yourself, and we can change these values to anything we want. Let's say we want that 5. Suppose we want this to be 55 degrees, and suppose we want B to be 7 centimeters. Okay, and now all of a sudden we have it, and it computes the other measurements for us. As I mentioned earlier, we will learn some techniques later on to compute these other things. You can click on that button later on to see the steps of those computations. But for right now, the idea is to be able to just to construct one of these with a compass and a straight edge and a ruler and a protractor, and then just simply measure the missing pieces and see what they're going to be. But in any event, we see that the big picture is that the side angle side postulate guarantees that once we know the side, the angle, and the side, in this case, whatever numbers we put in here, so many centimeters, so many degrees, so many centimeters, then there's only going to be one triangle of that size, and if no matter how many times we build this or where we build it, these other measurements are going to turn out to be 5.82 centimeters, 44.75 degrees, and 80.25 degrees with these measurements. So that gives you an investigation again of the side angle side postulate.